So now we've talked about the different types of linear functions, and we've also talked about how to graph the linear functions in slope-intercept form, point-slope form, and standard form. Now we are going to talk about how to write a linear function or inequality that best models a real-world situation. So first of all, we need to figure out, are we going to be writing a function or an inequality? And what is going to make that decision for us is if we are talking about a situation where something equals something else, and words that imply this are is or are, or are we talking about something where one quantity has to be more than or bigger than something else, such as I have to save up more than $100 to buy a camera. So words that imply greater than, which would be one of these symbols, either greater than or could be greater than or equal to, depending on the situation, are at least, more than, greater than, bigger than, or at a minimum. Or words that imply less than. For example, I have $100 in my bank account, so I have to make sure to spend less than that. So I have less than or equal to, depending on the situation. And words that would imply a less than situation are no more than, less than, smaller than, or at a maximum. For example, I can spend at a maximum $100. All right. Now, once we figured out if we are doing an equation or function or an inequality, next we can think about what type of function we're going to write or inequality. Are we going to be using slope-intercept form, point-slope form, or standard form? First of all, we need to remember that real-world situations usually come with a set of data in a table. Either this is given to us, or we can make it based on the situation. Here's how to write a function once you have that set of data. First, ask yourself when looking at the set of data, do we have the y-intercept? If we do have the y-intercept, you're going to use slope-intercept form, y equals mx plus c, because we can always find the slope, and that's where the y-intercept goes right there. That's the y. Next, if we don't have the y-intercept form, we can use point-slope form, because we always have the slope, because we just find that in a table, and here is where any point can go. So you can only use y-intercept or slope-intercept form if you have the y-intercept. If you don't have the y-intercept, you can use point-slope form. And you can always use point-slope form because you can always just pick out any part of the table. So for example, for this problem, let's write a function for this. Here is our y-intercept, and our slope is going up by 5 over here and 1 over here. So my slope is 5 over 1, or just 5. And my y-intercept is 0, 13. So the equation for this table of data is y equals 5x plus 13. Because my slope is the number that goes right before the x, like the m right there before the x. And the y-intercept is the number being added or subtracted to the x. Here, it's a positive 13, because that's my y-intercept. Now, if we go over here, we don't actually have a y-intercept. And we couldn't find one either, because the y-intercept happens, oh, we could, never mind. We could follow that back, and we could find the y-intercept. We could go 4, 3, 2, 1, 0, and keep following the pattern back and see what this is when x is 0. So we could get the y-intercept, but in situations like this, it is often a lot easier just to use point-slope form. So for point-slope form, you need the slope and any point. So here, from negative 3 to 6, let's find the slope. We go up 9. From 6 to 15, we go up 9. From 15 to 24, we go up 9. On the x's, we're going up 1, and up 1. So our slope is 9 over 1, or that really is just 9. Now we don't have the y-intercept, so we can just pick any point we want. And it really is any point we want. I will just pick this first one. You can pick any of these points. It really does not make any difference at all. So whatever is your favorite point. So I usually just pick the first one. So then we write our equation. So it's y minus the y-coordinate. Now the y-coordinate is a negative 3. So instead of writing minus a negative 3, I'm just going to write plus 3. Because if you subtract the negative, it's really just like adding. Equals my slope, which is 9. And then in parentheses, I do x minus the x-coordinate. So x minus the x-coordinate, which is 5. So there's my equation there. Notice, just like we've talked about before, point slope form, that if it looks like a negative 3 here, it's a positive 3 here. If it looks like a 5 here, it's a negative 5 there. It's always the opposite in the equation that it looks like what the actual point is in the table. Now, once you have your function, you can always ask yourself, does this make sense? Just plug in a few points and say, okay, if I plug this point in for x, does my y value make sense in the context of the situation? And we will practice that a lot more as we go. The last thing I want to point out that's not on these notes is we've talked about when to use slope-intercept form and when to use point-slope form. We haven't talked about standard form. We will do a lot of examples of standard form in class. So we're just going to add in a little thing right here that says use standard form when there are two, we'll say, items or variables or elements, I'm not sure what the best word is, two elements being combined to reach a total. And we will do practices with that in class, but I just want to add that in there right now. And this, I know, does not make a lot of sense in these notes to have this here because I haven't really explained it. But we will do a lot of examples in class with this. So that way when you're looking back at these notes, you'll know if I have the slope and the y-intercept here, use slope-intercept form. No intercept, I can use point-slope form. Or this is when I can use standard form. And that will make more sense when we do more examples in class. But you can have it in your notes just to remind you for future days. And that is all there is about modeling with linear functions. Happy modeling.